Understanding systems and systems thinking. Welcome to our channel Mindfuel TV. Please follow and subscribe to our Facebook and YouTube channels to get more useful videos like this. If you like this video, don't forget to like, follow, share, and subscribe. We live in a world full of systems, whether it's our bodies, the technology we use, or the environments we live in. But what exactly is a system asterisk? And how can understanding it help us see the world more clearly? In this video, we'll explore the types of systems, how they function, and how we can use systems thinking to understand the connections and feedback loops that shape everything around us. What is a system? A system is a set of components or parts that work together to achieve a common purpose or goal. Systems can be simple or complex, depending on how many components they have and how they interact with one another. Types of systems. 1. Simple systems. These are systems with straightforward, easy-to-understand components and interactions. They follow predictable patterns. For example, a bicycle is a simple system. It has wheels, pedals, a chain, and brakes, and each part has a clear function. 2. Complex systems. These systems have many interconnected parts and relationships that often result in unpredictable or dynamic behavior. An example would be an ecosystem or the human body. Small changes in one area can lead to significant, sometimes unexpected, outcomes in another. Characteristics of a system. Every system, whether simple or complex, shares common characteristics. Purpose. Systems exist to accomplish a specific goal or function. Interconnectedness. The different parts of the system are connected and interact with one another. Boundaries. There are limits to what is considered part of the system. Complexity. Systems can range from simple to highly complex, depending on the number of parts and interactions. Inputs and outputs. Systems take in inputs, energy, information, resources, and produce outputs, actions, results, products. Systems thinking perspective. Systems thinking is an approach to understanding how parts of a system work together. Instead of focusing only on individual components, systems thinking helps us see the bigger picture. It allows us to understand how changes in one area can affect the entire system. Interconnectedness is the idea that every part of a system is linked. Changing one part of a system will often result in changes elsewhere. In a business, for example, if the sales department increases product promotions, it might lead to more production work, affecting the supply chain and inventory. Synthesis is the process of combining all the parts of a system to understand how they function together. Instead of looking at each piece separately, synthesis helps us see how the parts interact to create the overall behavior of the system. In complex systems, interactions between parts can create outcomes that are greater than the sum of the individual components. This is called emergence. For example, traffic patterns emerge from the collective behavior of individual drivers, creating a flow that no single driver controls. A feedback loop happens when the output of a system influences its own future behavior by feeding back as an input. Feedback loops are essential for understanding how systems behave over time. Example of a feedback loop: consider a thermostat-controlled heating system. When the temperature in a room drops below the desired setting, the thermostat turns the heater on. Once the temperature reaches the set point, the thermostat turns the heater off. This cycle is a feedback loop that maintains a stable temperature. Types of feedback loops. 1. Balancing feedback loop. This type of feedback loop aims to stabilize the system by bringing it back to equilibrium. For instance, your body uses a balancing feedback loop to maintain a stable internal temperature. When you get too hot, you sweat to cool down. 2. Feedback loop with delay. Sometimes, feedback doesn't have an immediate effect, creating a delay. A good example is trying to steer a large ship. You turn the wheel, but it takes time before the ship responds and changes direction. 3. Causality. Every action in a system has a cause and effect. Understanding causality helps you identify where feedback loops exist and how they influence the system. If you change one variable, it will affect other parts of the system, which may loop back to affect the original part. Implications of feedback loops. Feedback loops play a crucial role in maintaining or disrupting a system. A balancing feedback loop helps keep the system stable, while reinforcing feedback loops can amplify changes and potentially destabilize it. Recognizing these loops allows us to predict how systems will behave and make adjustments where needed. System mapping is a visual tool used to represent the parts of a system and how they are connected. By mapping out a system, you can better understand the relationships between its components, identify feedback loops, and spot areas where things might go wrong. For example, in a business, you can map how customer feedback affects product design, which then influences marketing and sales. Seeing these connections helps you understand how changes in one area ripple through the system. System analysis is the process of studying a system to understand its structure, how it works, and how efficiently it achieves its goals. This analysis involves breaking the system down into parts, studying the interactions between them, and identifying any problems or inefficiencies. Tasks of system analysis: define the problem. Clearly understand the issue you want to address. Break down the system. Identify and examine the individual components. Identify feedback loops. Understand how different parts of the system affect each other. Evaluate performance. Assess how well the system is functioning and whether it's meeting its objectives. System engineering. System engineering is a field focused on designing, managing, and optimizing complex systems throughout their lifecycle. Systems engineers work to ensure that every part of a system operates efficiently and contributes to the system's overall purpose. They use tools like system mapping, analysis, and feedback loops to develop systems that are resilient, efficient, and adaptable. Whether simple or complex, systems are everywhere. By understanding their characteristics and how they function, we can apply systems thinking to make better decisions, improve efficiency, and solve problems in our everyday lives. Tools like system mapping, feedback loops, and system analysis give us the ability to see the bigger picture and create more effective solutions. Thanks for watching.